Hello, Internet. I'm back today with another fun JavaScript art thing, mostly in vanilla.js. Today, we're going to be making an image filter that applies a kind of mosaic effect based on the Voronoi diagram. What's a Voronoi diagram, you ask? Well, imagine that we have this large plane, and there's two people living in it. This green person and this light blue person. And decide that imagine that they have to mow the plane. But they want to split up their duties, and so they have to mow the grass, but they'll only do everything that's the closest to their house, which is where these points are. So then the light blue one will do everything up until the line, but then as soon as it gets to the other side, it's closer to the green person's, the dark green's point. Imagine a third person moves in, maybe over here. Now, as they split up the chore of mowing the plane, then everything that's close, all these points that used to be over here that were on the green side, they're now actually closer to the pink. And so as more and more people move in, we can keep shading the plane by which house it's closest to. And that's what the Voronoi diagram is. Basically, a mapping, wow, these colors are dark. Get some new colors, please. There. It's a mapping of, for every single pixel on this map, which of these vertices it's closest to. And this is a super useful concept, and it pops up a lot in real world applications. For example, you might be planning a city, you might be planning where the fire stations go in a city. And you'd like a map of your city shaded by which fire station is closest to every single block. Something like the Voronoi diagram was used the first time that somebody mapped an outbreak. By drawing a Voronoi cell around every water pump in London, John Snow was able to trace the source of a cholera outbreak to this infected water pump. Okay, so what our image filter is going to do is that we're going to load our image, and we're going to pick random points on the image, these little black dots, and instead of shading them random colors, like we have here, we're going to shade each of these little polygons by the color that's inside the point. And this is going to give us kind of random mosaic-y looking effects. There's lots of ways to get this kind of effect, but this is one I've done before and I enjoy it. There's a closely related concept, which is called the Delaunay. In fact, they're so closely related that to calculate one, you end up calculating the other. And the library we're going to be using to calculate this, it has Delaunay in the name. Let's get started. I'm going to be using this cool tool called Snowpack, which is going to let me get by without using a bundler and be able to have multiple files and use libraries. These days, JavaScript has the first-class concept of a library through a module script. And by using Snowpack, I'm going to get away with local development with modules, and I'm not going to have to install Webpack or anything complicated. I have Snowpack here, and it's going to host my HTML. Great. Oh, it's unhappy because I don't have a head tag. Let's give ourselves a title, Voronoi 5. Or, yeah, there we go. Let's also put a title. This is the title that comes up here on the left. And let's give ourselves one inside here so we can see it. Great. And each one should be in the body. Let's be fancy. I'm a huge sucker for Helvetica. Oh, yeah. Okay, and then let's add our script tag. I need src equals index.js is going to be the name of our script. And as I mentioned, we're going to be using an ES module script. Okay. Oh, it's unhappy because I can't find index. There it is. So here we're using our multiple files. Let's add our canvas. And I'm not going to give it a width or height. We'll set that based on the picture that we're applying the filter for. So let's get our canvas, our trusty get element by ID, and we set the ID on the HTML node. Get our context. The context is the thing that is going to be running the commands, the drawing commands that we're going to be giving the canvas. Oh, I'm so bad about semicolons. I just forget them or add them. Very inconsistent. Doesn't really matter. Computer will still run either way. We have our canvas, and let's do something just to make sure that we're good. Let's just draw a little square. Yeah, we got a little square here. Great. This means it's accepting our commands just fine. Let's start by actually setting a width, just to pick some dimensions. And let's make our canvases width and heights match these dimensions. Okay. The approach I want to take is I want to generate a lot of random points. I want to draw the Voronoi diagram, and then color in the Voronoi diagram based on the picture. Let's start by generating all those points. We're going to decide how many points we want up front. Let's say 1,000. And let's also have an array for our points. It turns out you actually can let your array, even though we're going to be mutating it by adding and removing, or most in this case, just adding things to it, we can still declare it as const because we're not actually rebinding the variable. This is just a little trick of JavaScript when they implemented the const keyword. So in general, we only use const when we want to prevent, when we only use let when we want to reassign the variable, not just modify it. So let's make our points. Const x equals math.random times width. Same for y. And then we're both going to floor them so that they're valid pixel values. And let's add our points to our list. And then let's log it out and see that they're right. An array of 1,000 things, and it has different values. Instead of drawing a fill rect at 10, 10, 5, 5, we could do at x, y. Let's make it a little smaller. Oh, this shows up just fine. All right. Here is a nice little set of random points. Generating a Voronoi diagram can be kind of slow if you go about it a more naive way, whereas the canonical algorithm to calculate is called Fortune's line feed algorithm, and it's much faster, much more complicated, and ends up dragging this straight line across the field and then keeping track of these parabolas. And I don't want to implement that today. Instead, what I want to do is use a nice library that someone else has written for us called D3 Delaunay. If you remember from earlier, the Delaunay and the Voronoi are kind of the same, two sides of the same coin. So this library is actually going to use the algorithm to compute the Delaunay, and then it'll transform it into a Voronoi for us. So let's start using this library. Remember, since I'm using a module, I can straight up import this from this URL, which is so nice. And then here I'm reading just how to use this library. And it looks like I import this Delaunay object, and then I give it a list of points, which are pairs of x, y. And then from this Delaunay, it lets me transform it into a Voronoi if I give it the dimensions of my image. Well, let's go ahead and do that. let's make our Delaunay. Delaunay. And we have an array of points, but it's structured slightly differently. It's an array of objects with x and y. So let's use the map function, transform it into an array of pairs. Map is going to run the function I give it on every single value in its array, and it's going to transform our array this way. So we're going to give it, if we're given a point, we're going to return an array, which is our pair, with the x and the y taken out of our object. And once we have our Delaunay, we can use that to transform it into our Voronoi with this Delaunay.Voronoi function that the library is giving us. Let's do here and then 0 width and height. Once we have our Voronoi, this library also has tools to render the Voronoi directly. I think it's down here. Voronoi.render. Let's try that. Let's get the rendering going on our canvas. I think we need to do context.begin path. What this render call seems to be doing is doing all the line drawing functions that we need, but we still need to call our context.begin path and our context.stroke when we're done. And then it takes the context that we pass it, and it's going to like send all the draw commands, and then we need to before this we need to initialize the drawing, and then afterwards we need to like send them out with the stroke function. Okay, let's see. All right, we have our Voronoi diagram for these random points that we've picked, and if we reload, we're getting different random points every time, and this is nice. What I want to do next is remove these little dots. Good. And instead of drawing the lines, I want to fill them with a color. It can be a random color for now. Because this is rendering the Voronoi in one go, we don't have time to inject the different fill colors, like paint this one red, paint this one blue. So instead, we can, I think there's a function to render an individual cell for us. And then for each cell, there we can inject I say inject, but all we're going to be doing is setting the fill style before every single render call. And I think there is cell.render. So since I know that later on we're going to be using a color from a picture, and we're going to store the color in this points array, I'm going to go through every point. And I saw earlier that there's a find function in the Delaunay, and it's going to give us the index of the cell that our point is in. And then I think we can tell it to render a particular cell here. We tell the Voronoi, Voronoi.render cell dx. And we still need our begin path, but instead here we're going to do, instead of calling stroke, which draws a single line, we're going to call fill. And we're going to set the fill style. Well, let's paint them all red for a hot second. And then let's see how that goes. This isn't happening. So let's make sure that console.log idx. Okay, it's not finding our point. That's right. That's because we need to call it with point.x and point.y. Oh, we forgot to give it the context that we're rendering the cell for. Great. So now it's painting all the same color, kind of useless. Let's pick some colors randomly at first. Here I've picked a random RG and B, and then I'm gonna use backticks and R, G, and B. Oh, nice. This is nice. This is already its own little piece of art. Okay, now instead of using random colors, I want to load an image from the file system and use the colors in those points to shade the entire polygon. To do that, I think we're going to need to do this a little bit higher. I'm going to load the image here. So we're going to have our image equals new image. And then we need to make its source equal to, I think I have a file called xmastree.jpg. And the image is going to be loaded into this variable, but it takes a little bit of time to download the image and load it into that variable. So we actually need to give it a callback, and it's not on the board. I think it's just, what is the actual function we're looking for? It's add event listener load. Okay, so when our image, let's move the code that selects the random points into the code that runs after the image is loaded. The reason we're doing this is that we need to wait for the image to be loaded so we can look up the pixel values in the image. What I also want to do is draw the image at first. Let's stop drawing the Delaunay for a second. Here, we're going to do context.draw image, image. I think you give it where you want to start. Great. Our image is a little bit bigger than 1,000 by 1,000, so let's also change that. We can do, instead of setting width and height down here, we can use image.width and image.height. And everywhere, probably we'll all move this code into also the code that runs after the image has loaded. So we need to resize first, and then we're going to draw the picture. There we go. Look at that beautiful Christmas tree. It's so big. There we go. Now let's look up the pixel values on the canvas at our X and Y points. What we're going to do is we're going to have a variable called color, and let's make a function called like get pixel value, and it'll take the X and the Y, and it'll also take something called the image data, which we can pull out of the canvas by saying get image data. We need to tell it 0, 0, width and height. And image data is actually an object that has many properties, like the dimensions of the picture. And then it has one of those properties is called data, and that's a buffer, a one-dimensional array of every single pixel value stored as RGBA, RGBA, and so on. That's what we're going to pass into our get pixel value. That image data. And we're also going to need to pass in the width. And that's because since our buffer is one-dimensional, if we want to ask for the pixel at row 37 and column 20, we know that, imagine the width was 100. We know that row 37 means that there is 100 rows of 37, and then we have to just add the remaining 20 from the Y, and that'll be the one-dimensional address of the pixel. Let's make a function here for our get pixel value. Function get pixel value. So it takes an X and a Y, an image data, and a width. So we need to compute this index. And if you remember, I was saying that the pixel values are stored as R, G, B, A, and then the next one. And that means that every single pixel takes 4 slots. So if we're looking for a pixel with the one-dimensional address number 5, it's actually going to start at address number 20 in the array because there's already been 5 groups of 4 RGBA values before it. So whatever value we pick, it's going to be multiplied by 4. Then it's going to be y times width plus x. And this is going to be our one-dimensional value. Then we can return r equals image data idx. And then g is going to be the one after it, and b the one after that. Well, image data is not defined. This is because we didn't save it in a variable. Great. This seems to be working. Let's log the colors. And let's log the whole array and open it up in the console and see that the colors have values that make sense. RGB 0, that makes sense. RGB 22, 19, 12, great. Now we can re-enable the Delaunay. And instead of picking, this is unhappy because I moved all this code. Let's move all the code back into the function that gets called after the image is loaded, right? The Delaunay also needs to wait for the image to load because we don't know what color we're going to be painting our cells. So now the fill style, instead of being R, G, and B, that are random values, we can say const RGB equals point.color. Wow, there we go. Here's our Christmas tree. All mosaicked. It looks extra nice. Here I up the points to 5,000. Maybe let's do 10,000. Very nice. And normally computing a Voronoi of 10,000 points can be a little slow in JavaScript, at least. But this D3 Delaunay library goes really fast. It's really nice. And I really like this mosaic effect in general. Here is an image of puppies I found. Have a look at how extra cute the puppies look when they're mosaicked. I love it. All right. I hope you enjoyed this video. I hope you enjoyed learning fun things with JavaScript and seeing some art along the way. Stay tuned for more and have a happy holidays. Stay safe.